In this video, I want to define some terminology that will be useful later. So we're going to fix Q a biring, and the biring is going to be over a base B. So we said, what do we say? We said A to B. Let's take it over B, and then what we're going to do is we're going to take a ring R, and it's going to be it's going to have an action by Q. So this is going to be the category of rings with an action by Q. And what we can do is we can look at this ring here. So let's take a number of indeterminates. And these are going to be indeterminates with respect to Q. This is going to be the ring Q composition product with, this means that we're given an action. Since we're given the action, here we're going to have this be the composition product of this with here. Sorry. We're going to take this ring, and the composition product is going to be relative to the given action. Okay, so this just looks like a ring with a bunch of indeterminates and a bunch of symbols for each operation in Q. So let's make some further assumptions on Q. Let's say that Q is going to be generated by, we'll say that it looks like B joined with a number of indeterminates. We'll always have the identity element, and then we'll say that we have just a finite number of other operations here, M. So this is a finite number of other operations. Let's say that it looks like this. Okay, and so this is a finite number of other operations. Theta 1 to theta m, so these are these algebraic operations. And then we're going to have, so this thing here is this is the monoid, so this thing here is what we'll call theta. And so this is the monoid generated by the theta i's. And in particular, it's going to look like words, theta 1, composed with, let's say theta I1, theta I2, etc. So it's just going to be a composition of these things, theta IM, or say theta I don't know, L, and this is going to be for L bigger than or equal to 0. So we just kind of look at this, all the words, these are all the words generated by the thetas. All right, and that being said, now we have this kind of this polynomial ring and indeterminates, and then we have this guy here. So, and then we're going to suppose that Q is generated by this, and sometimes there might be truncated versions of Q, but we're just going to take the full version, and this would make Q what's called a plethory or a composition algebra. Let me say more about this here. So this ring, I'm going to simplify some notation. So I'm going to take y just to denote y1 through ym sometimes. Actually, let's actually not do this. Let's not do this for now. I'm going to come back to that in a second. But I want to talk about if we talk about in a single indeterminate. So let's say a single indeterminate z. This is a single indeterminate. And what we can do is we can look at this ring RZ of Q, and what it's going to do is it's going to okay, so what does this look like? So this is going to look like a big direct sum of W is going to run over this weight space W of R to the Z to the W, and here W this is the weight space, what I'm going to call the weight space. And this is going to be generated, so this is going to be, well, n, and then we're going to take these thetas, the monoid of these operations here. So in this case, it's going to be this big monoid of things here. And what we're going to look at is so in something in here looks like, so a W in here looks like a formal sum of AIs to the theta i's, where these AIs are going to be natural numbers. Let's say I is equal to 0 up to some other number n. And so these AIs are natural numbers, and these theta i's are in this monoid of the operations. And what we can define now is z to the w, this piece here, is actually going to be, well, this is going to be z to this sum here from I is equal to 0 up to n of AI theta I. And this is going to be equal to, okay, and sorry for once, something came up. So this is going to be equal to the product from I is equal to 0 up to n of theta I. So we take the theta I and we apply it to z, and then we raise it to the ith power. Okay, so in general, so we can do this with more indeterminates. If z, or if we did with y and it had many indeterminates, y up to, let's say we had m indeterminates, then what we could do is we could write the same thing as this thing here could be equal to, so now we have multiple indeterminates. This is with a particular q. This could be the direct sum of a bunch of different weights, but now we're going to have a vector of weights. And this is going to be times y to the w, where now w looks like a tuple of things, m of them, and each wi is going to be an element of w, and y to the w is going to be equal to this product of y1 to the w1 all the way to y. Let's see, do we have m variables? Ym to the wm, like so. Okay, so I guess I was using m before, and this has nothing to do, this is just an arbitrary choice. So, so this doesn't matter, so that these two things don't matter. Here, we could take n maybe here and n here. So let's do that, and then take m to be the number here. So then if we do that, then we have m symbols. So this is only an n, and this is an n, and this is an n. So let's just keep this convention. Okay, so that being said, so that way we have that now everything looks good. This being said, we can we have this thing here, and everything looks like it makes sense now. Okay, so this is kind of this non-commutative monoid generated in these guys again. Okay, so let me do an example real quick. An example. Okay, so we'll take Q to be the biring for two commuting derivations. Then, so then this imposes actually some relations on the monoid here. The monoid will actually make it so that the derivatives will commute. And here, theta is going to be generated by let's say dds. I'm just going to do it with two variables. I'm just going to call them ddt. So let's say that they have two names, and then so we have derivative with respect to s and derivative with respect to t, and then we could do something like u to the 5 dds ddt squared here, plus dds to the squared plus 3. And this thing is just going to be equal to, well, we're going to do this 5 times. So we do d cubed of u ds dt squared to the 5th. We do this one, we just take du squared ds squared like this, and then times u to the 3rd power. Okay, and that's all that this means. That raising the weight notation. All right, so that's what weights are. That's how the weight spaces work. Definition. So a ranking is a term order is a special term order on this this ring satisfying certain properties. Certain axioms. And let me say this, okay? So we saw that this thing here was the decomposition of, so we had this direct sum where we had these things in the weight space, and maybe if this had n indeterminates and this had dimension n here of r times y to the weight, okay? So it's a term order on this thing satisfying certain axioms. And so to define a term order, it's enough to define it on this space. Okay, so it's enough to give an ordering on, okay, satisfying certain axioms. Okay, and note that it's enough to give, so enough to give ordering on this thing here, theta of y. Y is going to be the set of indeterminates, and this is equal to the set of theta composition product with yj. So j is going to go from 1 to the number of indeterminates, so we're going to set n here, and then theta is going to be in the monoid generated by the thetas. Okay, so this is the monoid generated by the thetas. And it satisfies the following axioms. It says that for all u in V homogeneous, okay, it says that by homogeneous we mean the disjoint union of these guys. It says that u is going to be always less than theta of u. And this is going to be true for every non-identical operator. And the other thing says that u is going to be less than v. When you have this, that this is going to imply that when you take derivatives, you're going to respect the ordering here. And so this is for all theta in this set here. So again, the non-identical elements of theta. Okay, so this is what you have. So these are just the axioms. So really, it's just a total ordering on these guys here. So it's enough to give an ordering here, and it's enough to give a total ordering here. So total ordering. Of symbols with primes on them, of decorated symbols. Okay, so let's let me now define some things. Okay, so let's take u to be in. Okay, so now I want to define some terms, and so I want to be able to talk about the highest degree term, the coefficient, things like this. So take u to be an element of here. So now we're going to say that y is maybe a couple indeterminates, and we have this situation here. then we're going to let u to the yw be the coefficient of yw in u. So here's the definition. Okay, then what we're going to define the terms of u to be equal to the set of, well, w and w, the weights, such that the coefficient of this weight is non-zero. Okay, so this is the terms of u. The pieces of u, we're going to define to be, well, they're going to be the things that look like y to the yi to the wi, where w is going to be here. When we take these things, and we're going to get a non-zero term from this w. Okay, and then it turns out once we fix a ranking on this set here, so once we fix a ranking on the set of variables, the decorated variables, then we can define the notion of a leader. Okay, so the leader of u is going to be, sometimes it's going to be denoted L of u. It's going to be defined to be the maximum of, with respect to this ordering that we fixed, of the pieces of u. Okay, and this of course depends on a choice of ranking. So it depends on the ranking or the term ordering that we're using. Okay, so now I'm going to give an example of a ranking. So let's give an example. Then let's take Q to be just the biring for derivatives. So the biring for all numbers of derivatives of a single derivative. And in this situation, we're going to have that, let's say, we're going to have a differential ring, and then we're going to have a single indeterminate. So this is a single univariate. This is what the composition product with R of Z is in this particular case. And again, this just looks like R with Z, Z prime, Z prime prime, etc. And so we have an infinite number of indeterminates. Okay, so in this case, we can say what a ranking is, and the ranking is completely determined. Is determined by the following. So we have that Zi is going to be less than Zj. If and only if, so this is maybe a round thing, if and only if I is less than j. And that's it. And so here, again, theta, and then we have a single indeterminate z. So this is just the set of, well, z, z prime, z prime prime, etc., so on and so forth. Okay, and then again, the monoid in this case is just looks like the thing generated by iterates of the derivative. So this is equal to the set of, well, you have the identity, then you have the derivative, then you have the derivative composed with itself, and so on and so forth. So this is what determines the ranking here. Okay, so for differential rings, and I guess in general we can define the notion of a initial and separant. So and I'm just going to go ahead and do this. So this is about the initial and separant. Okay, so what we'll be able to do is so we'll again take a ring, and let's take this will be a Q ring, and we'll have a thing with a number of indeterminates, and we'll generate it by Q here. And let's say that we fix a ranking, so we fix a ranking. So this is an ordering on the monoid, so this is the thing that generates Q, with the number of indeterminates, so y. And so y again is theta is generators for Q, and then y is just the set y1 to yn indeterminates. Okay, so we fix a ranking, which is an ordering here, and then what we'll be able to do is we have this notion of the leader. So so for a given element A in this ring, and I'm just going to use the shorthand here, so we're going to say that we understand that which biring we're talking about. We have this notion of a leader, and so this is kind of like the highest. We should think of this as like the highest derivative term appearing in A. And we'll be able to write A as the sum from I is equal to 0 up to some degree of A, where we have some coefficients. The coefficients are going to be in that ring, and we have the leader of A to some power I. Okay, so here, this AI here, these AIs are going to live in this ring again. Okay, and they're going to have smaller ranking. So these are strictly smaller ranking. Smaller ranking than the leader. Okay, and now I'm going to make some definitions. So the definition that I want to say is that the initial of A, so with respect to the ranking, okay, so we fix the ranking, and this is sometimes called I of A. This is equal to the term in front of the leader to the highest power. So this is equal to A to the degree of A. Okay, and this is just also equal to A, and then we'll have the leader of A to the degree of A. Okay, so this is the notation for the coefficient. The separant of A is, well, this is sometimes called S of A, and this is equal to the partial derivative of A. Well, now we're thinking of it as a polynomial multiple indeterminates with respect to the leader of A. Okay, so this would be here, so maybe this is equal to I is equal to 0 up to dA, and then we have I times AI, and then we have L of A to the I minus 1. So we've kind of taken this thing here, right, and so this thing looks like A0 plus A1 L of A plus all the way up to the top degree thing of and then we take L of A to the D of A, like so. So this is what this is equal to, and this is the initial, and then the partial derivative of this with respect to this leader is the separant. So maybe in examples in order. Let's take an example. So in this example, let's take Z is going to be a single indeterminate. And A, so then we'll take Q to be the biring. So the biring, let's say the plethora for a single derivation And then in this situation, so that we have r of z just looks like, again, r of z, z prime, all the way, an infinite number of these. And we can take an element in here, a, and we can write one down. So let's take a and let's write it as z prime cubed, a minus, and let's say some constant times z prime prime, and we can say z prime prime prime. We can take this squared maybe, and we can just write something random down. Okay, and a could be an element of this ring R. Okay, so in this case, the leader of A is going to be the derivative that appears in A with the highest power. So the leader of A is equal to z prime prime prime. So this is the highest power derivative. Okay, the degree of A, well, this is going to be, so we look for the highest power derivative, so this is 2. So it comes from this term. The initial of A, so this is going to be the coefficient of the highest one, so this is minus A times z prime prime. And then the separant of A, well, now we're going to take the partial derivative of this thing with respect to A, so this goes away. And then this just becomes a constant thing. So this is z prime squared. And then we have minus 2a z prime prime and then z prime prime here, this thing to the first power, to the 1. So 2 minus 1. So we took the partial derivative. Again, this is the derivative with respect to z prime prime prime. Okay, and so that's an example. Let me get some more paper.